One way to classify supply chain processes is as either a push or a pull system. To illustrate this, let's look at a simple example. Here at MIT in Kendall Square, we have a sandwich shop that's close by to our building. We go there a lot. And one of the things I've found over the years is you can learn almost everything about logistics and supply chain from a sandwich shop. So we're going to use a very simple example here, and I'm sure you have a similar type of store or restaurant right by you. So the idea is you got this sandwich shop, and this is a picture of someone making sandwiches by hand, and you see someone is cutting the bread here, and they've got some tomatoes ready and some lettuce. Some things are pre-prepared, and they're kind of making them on demand. As someone comes in, they order a sandwich, and they make it. So I went in a little while ago and looked in at the different type of sandwiches that they can make. And so if you figure a sandwich consists of, some kind of bread, some kind of protein, whether a meat or something, some kind of spread, and some toppings. And in this store, they had 18 different breads, 6 different types of protein, turkey, chicken, and things like that, different types of spread, whether it's mayonnaise, tomato, whatever, and different toppings, whether it's lettuce, tomato, all those different things. And if you combine those, that's 21,600 unique sandwiches that can be made. And that's only considering if I only have one topping. If I allow you to have 2 toppings, like lettuce and tomato, then that goes up to over 400,000. And if you look at it, the real total number, if I look at any combination, exceeds 1 million. So you have all these different types of sandwiches. Now, obviously, they're not going to have all these sandwiches pre-made and just waiting for you, but sometimes someone might want to come in and not wait for someone to make a sandwich. They might want to come here to this little area where you can see some pre-made sandwiches. Let me circle them right down here. They might want to come in and just get something and go. Because while having them custom made is great because you can have any one of 21,600 unique sandwiches made, sometimes you don't want to wait that long. So what I've got here are 2 very different processes for satisfying the demand for a sandwich. And so we give formal names to these. So the idea of a make to order is this example up here where I actually make the product once it's been ordered. So I'm doing it once someone has placed an order of demand, that's when I make it. Now over here, in this case, where I have the pre-made ones, I made those to stock or to inventory. Now you might ask yourself, how many do I make? How do I know how many of these kind of sandwiches to make? Well, that's the challenge. You're making it to stock, it's based on a forecast, versus making it by order, you're actually making it on actual demand that someone is requesting. And then you've got this third category, engineered order, where you're not making a traditional product. You might engineer something a little bit different for that customer. When they come in, they order something special off menu. So let's continue with this analogy, and let's formalize some of these ideas, what a push versus a pull is. So a push system, and this is essentially where you had the pre-ordered sandwiches, is where the execution, in this case making a sandwich, is performed in anticipation of an order. So what does that mean? That means I'm making my inventory based on a forecast, what I expect or anticipate to come in. It's proactive. So it's being done ahead of time, and it's based on a projected need or demand. You can contrast this with a pull system, and this is where I make the sandwich to order. So someone comes in, and in response to that order, I make the sandwich. Demand is known because someone actually placed the order. It's known with certainty, and it's reactive. I only do this when they come in, and then I have to start the whole process. So when you look at supply chains, there are very, very, very few that are all push or all pull, and we'll talk more about that in a second. But the idea is that you usually have a combination of them. And the point where your supply chain changes from being a push to a pull is sometimes called the push-pull boundary or the push-pull point. And it's the place where you're done doing inventory based on a forecast and you're switching it to actual demand. So let's continue on with our example, and let's talk about 3 sandwiches. Now I made these up, but these are pretty representative. So this first one is a pre-made sandwich, a ready-made turkey wrap. You see it's in this nice little plastic casing there. They make these ahead of time, the night before, the morning before, because they know they expect some demand. Then there's some signature ham sandwiches that they only make to order when someone comes in. And then I created an engineer to order one, a Dagwood sandwich, one of a kind that they make if someone comes in and they got to give special directions. So let's look how these 3 types of sandwiches flow through. Well, any one of these sandwiches has three main steps. One, you're going to buy some raw materials. Then you're going to prepare the components, whether it's the components, pre-slicing tomato, pre-cooking the chicken, whatever. And then you're going to assemble them, and then I'm going to sell them. And so the question is, how do each of these get accomplished for these three sandwiches? Well, for each one, for buying raw materials, you're not going to wait till someone comes in the door to order your ham, right? You're going to order that ahead of time. So all three of these, the ready-made, the signature sandwich, and the one-of-a-kind sandwich, you're going to order those raw materials ahead of time based on some kind of forecast. You're pushing. You're going to order those ahead of time. What about preparing the components? Well, for most of them, for the ready-made and the signature ham one, you're going to do that ahead of time as well. You can prepare and pre-cook some of the materials and the bread and things, but for this one-of-a-kind, you might have to start doing a pull. You might not prepare all the components until they order because it might not be a standard thing that you do. So you might have a strange ingredient that you don't even touch until they do that one-of-a-kind order. Final assembly, it gets even more differentiated in that the ready-made one, you're going to do that ahead of time. Remember, these are the ones I'm going to stock ahead of time to have ready to take, if someone can grab from the cooler. These signature ones, I'm not going to assemble it until someone has actually placed the order. And then down here for the one-of-a-kind, of course, I'm not going to assemble it until someone's placed that order for that one-of-a-kind sandwich. And then selling it, that's a pull as well. I don't actually collect the money until someone is actually there. So if I look at these, you can see where the push-pull point is for each one of these types of sandwiches. And so we can ask some questions though, because here it is, I've got a sandwich shop, simple operations, three products, and they're all sandwiches of some sort, but I've got three very different supply chains. And so you might ask yourself, which is the fastest for the customer? Which one will give me my product the fastest? And I think we'd all agree it's this top one, right? Because all I need to do, I don't have to wait for any of these processing time. It takes time to assemble. It takes time to prepare the components. It takes time, of course, to buy the raw materials. So this one would be the fastest, the top one. Then you ask the question, which is the hardest to forecast? And again, it's probably going to be this top one because I'm making all these decisions, not just the raw material to buy, how much flour and how much ham, how many components to prepare. I might pre-cook the meats, I might slice the tomatoes, but I'm going to pre-assemble and put them in these nice little plastic cases. So I'm doing all of that ahead of time. I've got to forecast each type of sandwich specifically. So that's going to be tough. And then you might want to wonder which process gives me the most variety. And certainly it's going to be these bottom two. Probably this one gives me the most efficient way of giving a lot of variety because what I'm doing is I'm postponing the final customization, right? Postponing it until I know exactly what the customer wants. So I'm postponing the final assembly in this case. So by doing that, I'm keeping most of my products in this component or raw material form, and I'm only using them when they get requested because like any sandwich shop I've been to, I'm sure you've noticed there's only so many ingredients, right? It's how they get combined that increases the number that you can have. So this is the simple example of three sandwiches, but let's think about it just a little bit more. What about pure systems? What about a pure push system? And this happens. You have pure push systems where things go all the way through. You've got to base your inventory on a forecast and all the way through. And you can think that it leads to higher inventory levels because you're making a guess, and we'll talk better ways to make that guess on what your demand is going to be. So it's based on a forecast, so you're naturally going to have higher inventory levels. You're going to have potential spoilage too. If you forecast too much, you might have too much that you expected, it doesn't materialize. But you will have faster cycle time because by pushing it, having it ready, then the customer, especially in the sandwich shop example, can come right in and grab it. Now for pure pull systems, these are very rare. These are unicorns. In class, when I ask this, some people come up with bizarre examples, but it's very, very hard to find a product that doesn't get started to be even thought about till someone requests it. So maybe some engineered order ones that are very, very, very unique, or maybe if you get water out of a stream that's already there. But if you start thinking about a pull system, is the sandwich shop, for example, you got to start baking the bread. No one starts baking the bread when someone places an order. So usually you'll have a combination of the two. You might have pure push, but generally it's a mix. And you always look for that push-pull point, and one of the things that you try to do is push that push-pull point further upstream. And you want to get it further away from the customer. And the idea is you're going to push the undifferentiated or raw product or the work in process, the components, push those to a forecast, and you want to pull the finished product as much as possible. So some of the benefits here of having this mixed system where you have a push-pull point, one is the idea of postponement. And this is the process that allows for efficient mass customization. And so I don't do the final assembly, the final customization until as late as possible. Think about putting a smartphone together with different colored cases. I could have them all manufactured in the plant with each of the colors, but then I'd have to predict and forecast how many of each color are going to be sold. Instead, maybe I want to segment those out and assemble those at the dealership. And so the idea is you postpone the final customization. And then it also does something else, and we'll see this in our next couple lectures when we talk about forecasting. By pooling these products, these components, or these aggregate components that are used in multiple items, I'm aggregating demand. By aggregating demand, my forecast accuracy improves because I have more products to balance them over. It's a law of large numbers. We'll talk much more about this. But the idea of pooling products improves my forecasting because I'm forecasting over a wider range of final products. So the key principles from here is, I love this phrase, that what you want to do is you want to maximize the external variety with minimal internal variety. What does that mean? That means I want to have as many sandwiches that people can take. I want to sell as many possible combinations with a minimal number of raw components and sub-assemblies. So I want to make sure I can have all these different combinations and find clever ways to be able to deliver that with a minimum amount of internal variety. Another concept that you might hear is the whole idea of wrap raw as possible. Keep your in-process inventory as raw as possible. What does that mean? That means you don't do final assembly. You push that back as far as possible. Okay, so this was push and pull systems, and we're going to talk more about these as we go. And maybe the next step that we want to talk about is how do you determine which product will go in which type of process.